Okay, imagine that we have two curves such that one is on top of the other. So if we graph it on the xy, let's imagine one curve right here. We'll call it y1, and y1 will be f of x. And let's imagine another curve right here, and we'll call it y2 equal g of x. And we want to evaluate the area captured between the two curves from x equal a to x equals b. Like so. So this is the area that we are interested in calculating. And it's very clear that if I did not have y2, all I had is y1, then the area captured between the curve, the x-axis, and x equal a and x equal b will be simply the area underneath the graph. Likewise, if I didn't have y1, all I had is y2, then I'll have the area between the curve and the x-axis from a to b. And the area, the shaded area, will be simply the difference between the two. Okay? So it stands to reason that if this is the area, well, the area will be the integral from a to b of y1 minus y2 dx. And we can write it as, since we have two functions here, I can write it as the difference between h of x and g of x. Okay? We can do it because if I subtract the area that's captured by the graph of f of x minus the area that's captured by the graph of g of x, then I have difference of integrals, but difference of integral is the integral of the difference. So I'm using that property, but this time in reverse order. So this is basically the formula that we're using. Okay, so this is, in a sense, the area of captured by f of x dx minus the area like so. Okay, but the formula that we'll use will be this formula right there. Or this one. So instead of doing two integrations, we'll do one integral of a difference. Okay? The theory behind it, this is essentially a theorem. The theory behind it can be visualized by the following. By the following sketch. Okay, so this will be on the next page, and let me show what I mean by that. So here we go. We'll draw another similar sketch to what I had before. So here's you have some graph which is y1 equal f of x. And here we have another one, which will be y2 g of x. Okay? If I'll pick up a very narrow subinterval, I'll call it delta x, like so. And I'm looking at this slice of area. Okay, I'll call this slice of area, if this is delta x, this slice of area will be delta A, where A is the area from A to B, like so. So A is the area captured between the two curves from A to B, but I'm going to start with a little thin slice. How thin it is, eventually it will be so thin that we let delta x approach 0, so delta x will become the differential dx. Okay? So what is the area? Well, the width of this slice, we can approximate it as a rectangle, and the height of this slice will be y1 minus y2. Okay? So delta A will be the width multiplied by the height, or the width is delta x multiplied by y1 minus y2, like so. Okay? So the area itself will be the sum. And if we have n pieces like that, so the area will be approximated by n pieces, so it will be approximated by the sigma from 1 to n of y1 minus y2, but y1 is f of x and y2 is g of x, so instead of writing y1 minus y2, I write f of x sub I minus g of x sub I, and I'll multiply it by delta x. Now, because remember the definition of Riemann sum, we're going to take a value of x sub I that is inside each of these interval delta x. They can be in the middle or it can be anywhere in between. And we denoted it by a little star, like so. So now we are looking at Riemann sum of a difference between two functions. Okay? And we know that the area exactly, if we let n goes to infinity, then we're going to say that if n approaches infinity, then delta A becomes dA and delta x becomes dx. Okay? So in A, the exact value will be the limit as we let n goes to infinity of the Riemann sum, sigma from 1 to n of what we wrote above. F of x sub I star minus g of x sub I star, all of it multiplied by delta x. We are still, as long as we are within the limit, we are within the delta x. Once we let everything go, then A will be, this limit is the definition. The limit of Riemann sum is the definition of the definite integral. Okay, so we'll use that definition. We're going to say this is the definite integral from A to B of f of x minus g of x, and now delta x becomes dx. Okay, by the definition of the definite integral. So this is essentially a layman proof of the theorem, that is the area between curves.